Hey y'all, I wanted to spend a little bit of time and show you how easy it is to run your own coding assistant model in the cloud for a team or for yourself that just runs. I think there's a ton of value in one, hosting your own stuff so you have your own observability, security, and control, but two, just to see how easy it is to run these models and how great the open source community is really incredible. There's been a lot of hype around Cursor and AI-based coding assistants, and in most companies, or in a lot of companies, it's impossible to use a coding assistant that's going to share source code with OpenAI or Anthropic or anything like that. Instead, they want to have air-gapped or control over what's going on, and this is a way you could get it set up really easily. So let's dive in. Our Hetzner servers here, I already have it set up to where it installs with an SSH key, or it gets created with an SSH key. So let's just grab our IP address and SSH in. So once we're up here, we have a ton of great stuff we can do. The steps that we really need to go through. So what do we need to do? We need to, one, install drivers. We need to install CUDA. And we need to install Ollama. And then last, maybe we get this thing behind a VPN. Get VPN it. First things first, to install the drivers, we really don't have to do much. Since we're already logged in as root, we can just install Ubuntu driver. So Ubuntu has this really nice auto install for, well, can't type and do this at the same time. There we go. All available drivers are already installed. Oh, silly me. Let's upgrade. This is a totally fresh server, so we'll do kind of everything. And then as soon as this is done, we'll watch this go by. There's been a lot of noise or a lot of conversations on X and through the dev community recently about how to host your own stuff, not using serverless architectures, managing off of one computer. And I thought this was a really cool way to show how easy it is to run something. There are other ways we can run this that are more, I would say, production ready, that are repeatable, using Terraform and scale, but it's not important for your first run. So if you've never SSH'd into a box, or you're just getting used to understanding how all this stuff works, before you start terraforming up or automating a server deployment, it's really best to just start with a fresh install, just like this one, and then work your way through all of the errors. So let's try again. And there we go. So now it's noticed that there's a lot of stuff to install. Mainly what it noticed, and you can see it just swam by. I'll go back up to it. Is it noticed that we need to install our driver for our GPU? So our driver will get installed. This will take a bit. I'm a big fan. I don't know, when I started developing software, I was doing a lot of LAMP stack. So we were doing PHP, deploying Apache into a single server with our MySQL either running on the same server or running in a very close by server. And one of the things that really helped me with is now, even in a container-based environment where I'm working with Kubernetes or something like that, I understand how the network works, the Linux systems work, the firewalls work. If something doesn't respond, it's likely a security group or a firewall issue, or you get a timeout. Those types of things really help you move faster. And when I think about DevOps, or what I love about DevOps, is it's this like control over the whole stack and the power over the whole stack, whether it's operating a server or writing software or debugging it, testing it, managing the database, the whole thing. There's some real freedom and real power in that. And I really like returning to these roots. Let's reboot. It actually, I think, tells us to reboot too. Cool, we're gonna wait for this. So what I was saying, the beauty of being able to manage a server is that you understand how it all works. And often I think the architectures of a single deployment are actually pretty nice. If you use, in the old days, we'd use Capistrano, but even a Git-based deploy onto a server where you're bouncing a Docker container is a really nice way to run a single app. You can run them at scale like this too. And what I love about being able to run them at scale like this is you can deploy to dozens of application instances and you don't deal with the complexity of writing Kubernetes configs and the difficulty of managing deep runtimes and workload management software or PaaS software. I don't think we need to be afraid of Linux. Let's see if we're back up. So we're back up. Let's see if we have our GPU. And if you notice, we have our GPU, this NVIDIA RTX 4000, no processes. And that's great. So the next step here is to install CUDA. And there's a little bit of a trick here because when you install CUDA just straight out of the Ubuntu repository, you end up getting a super old version. It doesn't work that well. You're off base, all that kind of stuff. So what I like to do is I like to go into NVIDIA and you can pick your Linux. We're x86-64 Ubuntu, and we're running Jammy. And so let's just install it from from a new deb. So we grab it, set up the keyring, and this is just copy pasting, straight up, easy stuff. Add it here. And last but not least, we install. And then make sure you go and look at these additional options, because what's going to happen is there's going to be an after install instruction. And so what we need to do is we need to do some other stuff after. We search this page for after installing. Where is that? Maybe it's back on here. And there we go. So there's these post-installation actions that we want to find. And these post-installation actions will set up your path and everything so that we can find CUDA. So anything running can find CUDA. And so on a base installation like this in Ubuntu, super simple. You're just going to add this stuff into your bash RC. We add the CUDA installation to our bash RC, and then we add this into our bash RC as well, since we're on a 64-bit operating system. And that's it. We can right quit that. And we should have. We don't have it yet because we don't have that in our path. And now we have CUDA. Heck yeah. So there's our CUDA. And if we reboot again, it would update our NVIDIA driver, but that's not super necessary since they're the same dot version release. So feels really good. Now we have the ability to run CUDA on our GPU and do fast inference. So what I like to do now that all this is here, and there's a couple things you could do, is I like to use Ollama. Ollama is super easy. It can offload a little bit to the GPU, and it makes life super manageable. And it runs as a service. So we install Ollama, and it installs super easily and super quickly. Cool. And notice there is a GPU because we set everything up and we're good to go there. And we have ourselves a service. So there's a few things I like to do if I'm running a coding server for a team. And so when I run a coding server for a team, I don't want Ollama to automatically load and unload the model. It defaults to moving the model outside of memory after about 5 minutes, just to give memory back to the system. It's thinking it's running locally. If we want to serve this out to the world or out into a VPN or something like that, I think it makes more sense for us to have this loaded up all the time. Ollama, when we started the service, it just starts with Ollama run or Ollama serve, and we can actually look at that just by looking at the service. If you notice, it starts with Ollama serve. Sorry, I said run, but it's Ollama serve. It's running the Ollama server in the background under its own user, and it's doing everything you'd expect. What I want to do, and I can show you before I change this stuff, is look at Ollama serves help. And it lists off a handful of really nice, and I'll expand my screen just so you can read these, really nice environment variables that they gave us. And it tells us where it's serving. If you notice this Ollama keep alive, how long the model is loaded into memory. It talks about how many GPUs we want to use. We only have one on this computer. It has some batching. It has other stuff that you can do as you make this a little bit more, production ready. For us to just host a very basic coding server that maybe could help a small team and have us have control and security over that coding server, understand what models it's running and all that kind of stuff, we can just what we want to do is change the Ollama host and Ollama keep alive. And we want to change both of those things because we want to serve this out to the open internet or to all interfaces, and then we want to keep the models loaded into memory. So let's copy both of these things, and then let's go back into here. And if we take this and we say Ollama keep alive equals 0, and 0 means forever. And the other one was Ollama host, and we make that 0.0.0.0. There's actually one more that I want to change too, which is there's some CORS issues if you try and use this with cursor. It's not beautiful, but you can. But you do need to change your Ollama origin as well to allow cross-origin requests. So let's change that too. And so if I do that, I can change this and do that. There we go. We want to reload the systemctl daemon so it gets the new files, and then we want to restart. Oh, and there we go. So now Ollama's running with all of those environment variables, and that feels great. Now what? That's a great question. We have everything, so we want to VPN it. Let's make sure it works on the open internet first. First, let's even try locally. And see what happens. So let's download Llama 3.1. And this should go pretty fast on a server. While this installs, let's talk about how we're going to do the VPN. So my VPN of choice is TailScale. I find it super easy. It's free for small users. You can pay for it for some more features, access control, that kind of stuff. It allows for you to create essentially a local network with really nice host names and all that kind of stuff. So that's how we're going to do this. So we'll lock this thing down using TailScale. Before we do that, though, we'll make sure that this works over the internet. So because I was typing a lot, but there's the Ollama run, how are you? And then I bumped a bunch of, or I pasted in there is what it looks like I did. So if we can see Ollama's running here. Maybe if we come back to my local machine, and we do something like, let's do like a curl, not that IP address. Yeah, we'll do that one. That's ours. And there we go. So you notice we're talking to our public IP address that was in Hetzner, and we're getting response to your testing assistant, just say hello. And it does. Boom. Beautiful. Absolutely beautiful. So we have this over the internet. Ollama's being served. Model's not getting unloaded. You can use any Llama or Ollama model that exists in to do this, as long as you have enough GPU, CPU. If you notice, inference was super fast locally, and if we go back to the server, we have decent inference speeds, super fast, just feels great. Cool. So now what I want to do is VPN. The first thing is I find this host name to be super silly. Let's change it. I like Marvin, the code assistant. So let's rename this to Marvin, and then I will, we don't need to reboot yet, but we will eventually want to reboot. You can also reload the host name, but I find it nice to just reset everything and make sure it's nice before it's up and running and monitored and all that kind of stuff. Hop into a Linux and just grab this and run install. This will install everything we need for TailScale. It'll add Marvin after I reset the host name. Cool. Let's just restart. All right, we're back. You notice TailScale's up and running, feels great because we did the reboot. We have our new host name, and we also have Ollama running. Very nice. All right. So now that we're in TailScale, let's log in. And now that we're logged in, I can connect on TailScale to a tailnet. That's just, I think, like a VPN network. And if you notice, I have a handful of servers that run, and Marvin is right here. And if I disconnect from my server, I can actually say SSH root at Marvin. So I get this really nice DNS and all that other stuff. Now my server is still on the internet. And so Marvin is associated with a public IP address right now, and that's okay. I want to take this server off the internet, but for now, this is a great first step. Now we're going to use UFW to lock this thing down. TailScale has a really nice guide on their website that is just literally how to use UFW to lock down an Ubuntu server. And so we're just going to run our way through this. So we've installed TailScale. It's up. We want to first SSH into our server through TailScale. So if we go in this way, I actually think coming in this way should have used the right IP address. Let's just check. Sure. I think we are all right, actually. And if we grab out of our TailScale admin panel as well, we have here Marvin. We can grab our full IP address here. And so let's use that. So let's hop off and come in this way. The reason we want to come in this way is we're going to lock this thing down. So we notice Marvin is also the same key, so that's all fine. It's all signed the same. So now we're going to turn on UFW, enable UFW. We want to come in that way. We're fine. And then we're going to copy paste this stuff. So we want to deny incoming traffic, deny outgoing traffic, or allow all outgoing traffic, sorry. So it means we're going to block everything coming in and allow everything going out. We can look at our UFW here. It doesn't look like mine has any rules right now, so I want to allow in on anything coming from TailScale. So UFW allow in on TailScale 0. And that should have done it for both. And so now if I look at the status, we have it there, and everything's coming in there. Beautiful. Theoretically, when I exit this server, I should be able to come in only via TailScale. And let's reload TailScale, or reload UFW, and then we can try to come in here through this. And if you notice, no luck. We still have I did leave this connection here just in case something doesn't work, but when something times out, that means it's not going to work. And if I come in through TailScale, boom, we're in. Beautiful. I don't know why it took a minute. Let's just make sure that one still hangs. It should just time out. Beautiful. All right. You can restart SSH just as final. Good to go. And you're good to go. And so if I go out, it's always scary doing this. I should be able to get right back in through Marvin. And we're in. And if I come out and try to get in through the public IP address, we're locked down. I just cleaned up the workspace and I want to show you something neat. There's been a lot of hype recently about Cursor and coding tools and assistants and all that kind of stuff. And Cursor right now is really great, but it also is pretty limited in what it allows you to do. And so what I want to show you is right now with Cursor and a custom model, it's nearly impossible to run if you have it unloaded off of the internet. But TailScale does have some pretty cool features that allow it, that make it possible for Cursor, but you are opening up some security holes. So right now we have our model, it's hiding behind our VPN, just like we thought. And we want to get it to where Cursor can talk to it. So right now, if I come in here and I try and access our model, and I say, Cursor, use this OpenAI endpoint, save it, and then talk to it, it's not going to be able to. And the reason that is Cursor is actually sending your AI requests up to the Cursor servers. They're doing some prompt engineering on it, and then they're taking that and they're sending it over to this OpenAI endpoint. And because there's no public access to that OpenAI endpoint or that endpoint in general, it can't even resolve this DNS. Like Marvin is not a real DNS. Doesn't matter if we use a private IP address or anything. Cursor can't get there. And so what we could do, the easiest thing we could do is come up into our server, which we are here, and we could just say UFW disable. And we can disable our system. We can grab our public IP address. It'll hopefully render something here. Yep, there we go. Boom. I don't know why it was so slow. So if we come back up and we re-enable our firewall, and we say UFW enable. So now we come back in here. Yes, we want to enable it. And we come back in here and we try to do this again. Cool. What TailScale can do is it has this really cool feature called TailScale Funnel. And if we look at what it does, TailScale Funnel exposes a port over a domain to the open internet. Now, it does it through HTTPS, as we will have to enable port 443. And so with how we want to do that is we'll just UFW enable 443. Now that, or sorry, allows 443. We hop back in, and now we can say, oh, UFW reload. There we go. And now we want to get UFW working. And then we can say TailScale, reset our funnels just in case there's something running. And then we say funnel the Ollama port. And the Ollama port is now being funneled to here. And so if I come in here, I can actually use this. And I'm not going to use 443 here. I'm going to use that. I'm going to save that and try again. And notice we're connected. Now this is my model running in Ollama up in the cloud, managed by me. TailScale is able to access it, or exposed via TailScale, so Cursor can access it. And if I want to disable access, I can go kill that tunnel and then try to re-talk to it, and Cursor has no ability to talk to it anymore. I can show you also if I disconnect from my tailnet. Oh, actually, hold on. We got to come back in there. So if I connect to my tailnet and I run that funnel, but I run it in the background, so when we disconnect, it continues to go. I can disconnect from my tailnet, save this, and this will run again. Notice it's on the internet. There is no way to do a Cursor model or a Cursor custom model with a model that is locked down. So it has to be exposed to the internet, but this is a nice little hack to let you do a model on a custom model or your own hosted model available to Cursor that can be taken off the internet when you don't want to use it. So say you like shut down at the end of the day. So I can come in here and just say, I have to reconnect so I can SSH in, but then I would come back in here and I would say TailScale Funnel reset. So there you go. I think this is a really nice way to show how easy it is to run a model up in the internet and how easy it is to connect to it. You can connect to it with anything. There's other coding assistants out there. There's continue.dev, and there's a few others that I think are coming up, some open source, some not, that allow you to use your own hosted models or a open source model rather than going through servers you don't control. So I hope that you all enjoyed the video. Always like and subscribe, and I can't wait to do more of these. If you like the more opsy side of AI, let me know, and I cannot wait to do more of that. I can show you monitoring, we can add multiple nodes, we can host larger and larger models, we can do a bunch of that kind of stuff. So let me know in the comments what you enjoy, and I hope to see you again next week.